Hi my friend, and welcome on this video. And today we will be talking about stable diffusion. What is stable diffusion? If in case you don't know this already, it's a tool or neural network that you can use actually to generate images from text inputs. There are a lot of videos on this topic, and you will definitely find additional information on that on YouTube. What we'll be focusing on in this recording is what I've been trying myself to integrate stable diffusion support into the NervProj project. So what I should mention to start is that yeah, at a a long time ago, I was already playing a little bit with stable diffusion. It was at version 1.4 at that time, but lately I wanted to check that, and I've seen that we are already at version 2.1. So I thought I should give this one a try, which I did. Except, I've even created a fork of the repository here, so I've prepared everything for that. Except that this model is a giant plant, and giant gas plant, you would say, I guess, in English. And even on my RTX 3090, where I have about 24 gigabyte of memory, I don't have enough memory to run that. I mean, if I try to generate a large image of 768 by 768, I think that's the maximum resolution that you can ask the model to output. If I reduce this resolution to 512 by 512, yes, it's working. But 512 by 512 is actually the resolution we have in stable diffusion 1.5 and below. So I thought, okay, maybe it's better to focus on 1.5 and check what are the optimized models that have been created to run this, so that you can run that on using less GPU memory. It's a bit slower, of course, but at least you can use it. So I went back to version 1.5, and I used this repository as a starting point, as a new starting point. So on this repository, you have everything you need to run stable diffusion and this optimized SD folder. And in there, you have additional scripts that are going to cut the image you want to generate into PCs, I guess, or something like that. And well, handle those PCs separately, one after another. I don't know exactly how it's working, but it's using less GPU memory in the hand, so you can go ahead and use that to produce big images. Relatively big images. It's still not very big with all those generation system. Anyway, so these are the two files that I've been considering mostly. And we have that here for the text to image, and this one for image to image. And from that, I have created, oh, that's not the proper one. Okay, I've created a dedicated folder here in NervProj, in NVP AI Stable Diffusion, where I placed everything I need to support this image generation system. So, what should I say about that? I started with the text to image, of course, and I took basically everything you have here, trying to figure out really if it's really needed, and if it's really what I want myself. So I made a few small changes already, and this is a component that have been created. So you have mostly all the command line arguments that you could find already in text to image. So we have that supported here. And what's going to happen? We have this text to image command, and at the very beginning, well, very beginning here, am I recording? Yes, I'm recording. At the very beginning, that's where we're going to handle this command, and we go directly into handle text to image here. This is where we start to have some copy of the existing script from this source file. So it's a bit similar, but at the same time, I made a few changes. I added some comments, and it's not exactly the same mechanism. But yeah, I'm reading a lot of parameters this way, preparing a specific output folder. But then, yeah, still doing something similar with the models. And that's a big part where we run the things in the Torch node-RED. What is very noticeably different is that I've actually merged both scripts together. So we have this text to image on one side and the image to image on the other side, which is very similar. The script here is very similar to the first one, except that we are going to provide an initial latent representation instead of just pure noise. So I thought, okay, I'm not going to repeat the script again, and I like to optimize things by yeah, using small blocks that you can stack together. So I'm trying to go this route and try to reuse the same elements. So that's what I did here. And maybe just a first quick test on that. So let's say I want to generate some kind of logo. So let's go here and create just a new folder, which I will call test logo. Okay, it's currently empty. And what I can do is, I mean, I could also navigate in there. Yeah, so if I go in test logo here, Control D, I can open, yeah, entrance. So I get back to this, but first we need to use this NVP command line entry. The command we want to execute is ext to image, and we give this just a prompt. I didn't really think about this, but what should I try? A logo for a Skynet company preparing to build robots. To help humanity. Yeah, just that. So normally with just this, it should work. I hope so, at least. Yeah, I'm going to load the Stable Diffusion 1.5 model from the TKPT file here. Instantiating, blah blah blah. Yeah, let's pause the recording and get back to you when it's done. So it's running, yeah, PLMS by default with 50 time steps. Okay, so the generation is done and it produced 5 different images which we have available here. So from this folder, I can display those images. Oh, I mean, it's actually not bad. I mean, not really precise. Text are unreadable. But yeah, interesting result. The point is, I think the prompt that I'm providing is pretty poor, and you can make this much more detailed. So That would explain why if you play that, that's a image that you will generate maybe not so good, but it can be improved largely based on the prompt, I think. What I actually implemented also in there is if I go, for instance, just this test logo folder, and I try again NVP text to image prompt. I should probably use exactly the same one. So blah blah blah, up, Control C. You see here it used the seeds 42, 43, 4, 5, 6. And the way I implemented that or modified that, it's going to continue with additional seeds depending on the number of files that are already available in the output folder. So it should continue. Also, I'll rename those files to have the image index at the beginning. And it should continue with seed 47. So let's run that directly in Visual Studio because the display here is a bit pitiful. It's adding a new line every time. Not so good. So yeah. So again, let's wait just a little bit. Okay, so the additional images are generated now. And if we go and have a look at this, you see that it's continuing with seed 47, 8, 9, 50, and so on. So yeah, well, interesting. Okay, why not? Okay. Okay, now let's say, for instance, I'm interested in this version here, and I think it could be made a little bit better. Then I can actually start from this one. What's the name of this one exactly? Let's just copy it, otherwise that's the second one, right? No, the third one. 44. So take this as an image. And what I did, in fact, is, as I said, I merged both text to image and image to image scripts. So we can just keep using a text to image here, and additionally we can specify image, and for that we're just going to use the image that we already generated. Except when we do this, currently I still have to specify the sampler that I want to use because TLMS is not working. In fact, for image to image there's something broken, I don't know why. And also the strength of the transformation should be specified here. I'd say at the beginning, strength 1 means discarding everything, I believe, from the input image. Yes, the strength is the strength of the noise itself. Actually, we could just have a look at that maybe in the code. What do I do with the strength? Code. Yeah, never mind. I don't know. But yeah, I think if you set that to 1, we're going to discard the input image completely. 0 means we keep the input image completely. So 0.4 is a good starting point. Maybe a few more steps. DDIM steps, let's say 80, because this will be reduced a bit. So if you just use that, it should start with our input image here and produce some variation around it. So again, we'll be waiting just a little bit. Okay, so those I don't know if we can hear the cat. I hope not. So those new images are now generated. Let's see what we have. That's oh, okay. So that's the 5 new images that we generated. Oh yeah, maybe we should allow for more destruction of this image and also specify that it should be centered. Okay, let's keep those for the reference, but now we can maybe centered logo, and we can put more variation. 8. Professional logo. High resolution, sharp, sharp lines, curves. Yeah, I don't know. Okay, so let's again have a look at the new images. Wow, this one is cool. A bit less cool. Interesting. Yes and yes. Well, okay, so I probably need to do a lot more iteration to get a nice logo, but at least I think you get the idea now of how we can use those scripts already. Maybe just a quick word on what is really needed if you want to have a trial. So obviously you need the NervProj repository, so that's on GitHub and you can freely access that. I had a link again in the description of the video. Then what do you need? We also need the weights for stable diffusion 1.5, which are not included in the repository because you don't have the right to include them by default like that, I think. And it's a very big file at the same time. So if we go in NervProj, for instance, all I had to do was I created this data folder and then stable diffusion, and then I put those weights. And this one, oh no, I want to open that. Only this one is needed. Where can you find that? I think you can find that on Hugging Face if you just search for stable diffusion. Yes, 1.5 here. La da 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 da. Where is the checkpoint? Oh, yeah, those one. So this one only is enough. Again, to download that, you need an account on the Hugging Face, and then you just download this big file. Where is it again? Here. You rename that to SD-V1-5. And in fact, then we have this nvp.bat in the root of the repository. So if you add this folder to your environment variable path, then you will be able to execute nvp from anywhere. And just typing this command, for instance, would work, except that the first time you type that, it's going to set up the stable diffusion Python environment. Where is this defined? It's defined in the configuration file that we have for the full project here. This is the command that you're running. Oh, by the way, we have turbo activated here by default. You could maybe remove that. It's taking 1 GB of GPU memory, but it's making things a bit faster at the same time. And so the environment that will be initialized is this one. I've been working a bit on that and simplified this environment compared to what is suggested to do with Conda and everything. So I'm not even using Conda here. But the first time you will set this up, it's going to take some time because, for instance, downloading Torch is a close to 3 GB package. So that's a long process. Oh, and also on your computer, you need NVIDIA GPU. I'm not sure it's going to work with AMD GPU. I think it could, but not sure what's the thing with CUDA in Torch when you have a AMD. But if you have NVIDIA, you also need at least to install CUDA 11.3 because that's the one that is used for Torch 1.12. And so you start actually with installing CUDA, and then you can just run this command. When the environment setup is done, it will execute the command and generate some images right in the folder where you are. And that's it, folks, for this video. It will be pretty long already. What I just need to mention now is, well, with those investigations on stable diffusion, I eventually found this other project here. So Stable Diffusion Web UI by Automatic 1111. And well, this one is really amazing. I guess it's basically the next step compared to just using Stable Diffusion. I didn't even know you could do so much additional things. You can actually use different models. In fact, there's another channel that I found also, this guy here, explaining how you could use a lot of additional models with this web UI interface. You can insert your face in the models that you're using. So wow, there is really a lot that can be done. So when I've seen that, the idea I got was, okay, now I should try to build this, but I don't really want to make this as a web UI. I think I want to make this as a dedicated desktop application. So still in Python, but using PyQt, which I'm used to, so it should not be that tricky. And that I think would be a good journey, a good experiment for me. So I will get used a bit to what is used in this interface and learn a few things hopefully. So we'll start next time, and meanwhile thanks for watching and see you another time. Bye bye.